It's time to mention our good friends at Kintronic Labs. These guys are they're there all around the world. They just recently did a 100-kilowatt directional in South Korea. They've been going since 1949. That's 73 years, starting with Louis King. And now we have third generation with Joshua. And Joshua's going to be with us sometime, I think, in January to do a little presentation. We're looking forward to that. Kintronics is there, AM, directionals, FM, everything that you might need, from dummy loads on up to the diplexing and just filters, whatever you might need there. And they have their store now online so that you can order things day or night and find out if they're in stock and how much and all that good stuff. And so whether you're looking for a directional maintenance or you're looking to work on your FM, please remember our friends at Kintronic Labs. It's my pleasure today. It's another actual protection if you want, knowing what's going on at your transmitter, knowing what's happening. And broadcast devices have been making controllers and monitors for years. How long, Bob, have you been going?
Well, the company's been around since 1985, so we're going to enter our 38th year in business. But the RF business is going back to about 2007, when we formed a sort of an informal partnership with ERI at the time. And they're still a good customer and a good supplier to us. So that's what we've been doing. We've been building a product line, the RF support product line, since that original product that we developed for them, which was a motorized switch controller, which we're going to talk a little bit about today.
Yeah, let's start there. And of course, if anyone has some questions or about your other products and thoughts, we'll wander.
I'm an open book. I will answer any question. So it's kind of appropriate, Barry, that you were talking about protection, because what I'm going to do. Let me get this thing started here. I got to share my screen first. So I started to say that this is appropriate because I decided to when I started to do this presentation, I had one I did about a year ago, which is RF site safety. And I thought, actually this plays into everything that we do. We make monitors, we make remote controls, we make annunciator panels for RF safety monitoring and all that kind of stuff. So I decided we'll start with this. Now, about a year ago, of course, the FCC, they've made some changes to, they and OSHA have made some changes to the way RF safety is supposed to be handled at sites. And we all have to deal with this at RF sites now. Most of us have to only deal with the occupational safety standards, but on occasion, and I have had this experience where we had to deal with the public exposure as well. When I was dealing with the things at the Empire State Building, we had an outdoor observatory there that had to be treated with kit gloves. So you end up with both. But for the most part, this really centers around occupational exposure and some of the tools that we make that help you be able to do that a little better. So talking a little bit about an RF safety program, and everybody, if you don't know by now, you're supposed to have a written RF safety plan for every site that you manage. That's got to be available, and you have to follow that safety plan when you're going to do any work at a site. So the first step in that is to develop the measurement program to determine the actual RF levels that are. I'm going to read this because you probably can't see this very well. I don't like reading a presentation, but unfortunately, I'm going to do that today. So you have to make sure that the operational areas that you're dealing with are safe, and what those levels are, and plan accordingly. So based on the above, you develop an operational plan that may include reduced operating RF levels that provide the RF generator. That's you guys that are making the RF. with reduced power operation, and at the same time, you can provide a safe operating environment for occupational personnel. So it allows some flexibility if you can do it that way. You can develop a monitoring system that provides accurate assessment of operational condition at a given site. So in other words, here's the case in point example. You may have a site that's got a lot of antennas on it, and in order, the draconian method is if you're going to climb the tower or you're going to do work around the site, you're going to shut everything off. Well, nobody wants to do that, and if you're going to do that, it's usually in the middle of the night and all that good stuff. But if you can determine that you can operate a particular antenna or series of antennas at certain power levels that have been measured, you reduce power down to, let's say, 50% or 25% or whatever that level is, and it becomes a safe operating environment for occupational exposure. It's a win-win because you can keep stations on the air and your work can get done. And sometimes it can be done during the daytime and you don't have to be shutting down. It's all very expensive. Well, how do you ensure that? Well, first thing is you have to make measurements, and you have to have an accurate way of determining what is feeding a particular antenna. There's no better way to do that than with one of our products, the power meter, for example. So RF power monitoring is one way we do this. Another way to keep people safe is RF status indication. So there are various ways of doing that. You can have a RF safety panel. We've delivered these to many sites where they're tied into our power meters, and you can calibrate at a certain power level, a power reduction, that will turn on a safe light. And if it's above that, the RF on light will come on. So you have a quick panel, which I'm going to show here in a little bit, that will indicate whether it's safe to operate in that area or not. But the key thing is you have to have an accurate power meter to do that. And without that, you're just guessing. So you have to be very careful. So RF alarms, you can have that. We've done that also for sites where if you enter an area that you're not supposed to be in because there's RF applied, it'll sound an alarm that's tied into these panels that we make. And they can be in the form of a very loud klaxon, or they can be a light, or both. So there's various ways you can handle that. And then, of course, the last thing is on this page here is on this particular slide is probably the most important, and that is logging of events, because there's nothing better than having actual information about when RF was turned on, when it was turned off. And of course, the other things like other events like VSWR trips and that kind of thing. And then also status of lockout tagouts. A lot of sites these days have lockout tagout systems where once it's locked out, there's a short across the transmission line, and you're not going to apply RF to it at all. It would be good to know whether those things are on or off, and so we can provide indication for that. Okay, so I'm really sorry this is so darn small, but oh well. I talk better than I make pictures anyway, so let me just keep talking. The real key product that we sell for basic power monitoring, VSWR protection, and then for these RF monitoring systems is our DPS 100D series power meter. And of course, we make these in every size from N type all the way up to 9-inch EIA. We've made them put them on waveguide. We make them, in different frequency ranges for different services. Certainly for radio and television, we make, 88 to 108 for FM. We can do AM now, particularly for digital AM. These are not your father's bird meter here. Not to use my competitor's name in vain, but we are doing true RMS power measurement, so we can handle the high crest factors of the digital formats, whatever it might be. And we've actually made meters. We build meters for other industries. There's a lot of places where RF is used outside of broadcasting. Hard to believe, isn't it? But military and scientific applications and industrial applications. So the frequency ranges for some of these applications are pretty exotic. We've done things down to handfuls of kilohertz up to about 4 gigahertz. So whatever type of range you might have, we can generally handle it with the right type of directional coupler and the right power handling. The biggest one we've ever made was we did a set of meters for an industrial application where they were using a custom-made 12-inch transmission line. And I'd never seen anything this big, to tell you the truth. It was a coaxial transmission line. And the power levels that we were asked to come up with a full scale indication for were, and this is not an effective radiated power, this was an actual RF power level going through that 12-inch directional coupler, was 2.5 megawatts. And I can't tell you what the application was because we were under NDA when we provided this, but so we we can do some interesting stuff. Okay, let's keep moving along here. All right, this one's going to be really hard to see. Some of you may have seen this before. This is our calibration triangle. I call it the triangle of doom because it starts up at the top with the National Institutes of Standards. And this is basically how we derive our specification for error in our meters. And I think a lot of other companies do something similar. But the calibration standard that everybody uses will be a NIST standard in the United States, the National Institutes of Standards and Technology down in Gaithersburg, Maryland. So if you send anything to them, they'll calibrate a power meter for you for a very, very large sum of money. But most companies that do what we do don't, well, wouldn't you know it, I didn't turn my phone off. So let me get rid of that. Sorry about that. I'm just totally prepared today. So we use a laboratory standard. Now I want you to pay attention to the column on the left. There's plus and minus 1% marks on the left-hand side of the column, and we're going to start adding those because that's the delta or the best accuracy that you can get from these various standards. So if we take anything and send it to NIST, whether it be a power meter, which we don't do, we have our own calibration standard in-house. But if you were to take one and send it to them, the best that they'll be able to do is to tell you that your meter would be no more than 1% in error to their standard, to their calibrated standard. Now it might be more than that, but that's the best accuracy they can get. They can't tell you that it's any better than that. So the secondary standards that most companies use, and it either is calorimetry, or in our case, we use a calibrated reference oscillator to do our calibrations, are calibrated to that NIST standard. So we're one rung down on the ladder here. That's the yellow part where it says lab standards. And so we have to add another percent. The reason for that is because when we perform a calibration and then we go back and we measure the same unit that we just calibrated, you could have it as much error as 1% between the calibration standard that we're using. It's the same thing as NIST, except that you have to accept the fact that the NIST standard these things are additive. You have to add that to your error. So now we're at about 2%. And then we go down one more, we're down to other lab and test equipment and fixtures, which add error. Of course, a calibration of a power meter, an inline power meter has really there's two parts to it. The first part is the actual power sensor itself. Most of you, anybody who's worked in television is probably familiar with, the old HP power heads, and they make the EPM now, and I guess it's not HP anymore. It's Agilent, and of course Rohde & Schwarz makes some really good meters as well. And so that's just a power head. But you need a directional coupler if you're going to do inline power measurements. So every one of our meters is an inline power meter. So you have to calibrate the directional coupler as well. So there's another piece of test equipment used for that. It's called a vector network analyzer. And that analyzer has to be calibrated to the same standard. And that's that standard that's up here, the blue standard. So add another 1%. So now we're down to the orange portion of the triangle, and that's other effects such as coupler directivity, temperature variability, handling, and long-term effects. Well, that's a lot of stuff. Temperature variability, we've made measurements on that. It's about a 1% delta over the entire temperature range of the meter, which is 32 degrees Fahrenheit to 150 degrees Fahrenheit. We don't recommend that you run them that hot, but but we actually made tests to see what the change in percent would be. So there's some variability here. And then of course down at the very bottom is where you're going to then compare this to another meter that might be the meter that's in the transmitter or whatever, and you can add another 1% because that meter has got the same set of errors. So that's, if you go down to the very bottom here, you end up with plus or minus 5% of indicated reading. And over on the right-hand side, we've been counting up delta, which is the, the plus and minus range. So that's 10%. So that means that you could have two meters that are perfectly calibrated and meet specification and could be that far apart, because one could be, you can assume that one would be in one direction, one would be in the other. Generally speaking, that's not the case. It's usually something somewhere in the middle. The average is usually a couple of percent, but it can be, it could be as much as 10% and still be technically be within calibration. Okay, so enough about that. Let's see where we are here. All right, so I mentioned status monitoring earlier. So this is a panel that we make. This is what we call our RFS 120 panel. And what this does, it's got a bunch of LEDs on it. And the top row of LEDs are the safe LEDs. And the bottom row is RF is on. So only one's going to be on. Okay, either it's safe to transit through an area based on whatever's connected to that particular channel, or it's not. And if it is safe, you'll get a green light. If it's not, if it's above threshold that you set in our meter, this is done through the DPS 100D power meter. There's a relay that you can set up for, for our sensing RF, and you can set that down to 1 watt if you want to, or up to some level that that you can operate when when you need to have some RF safety indication or whatever you want to set it for. But in any case, if RF is on, you'll have a red light, and if the green light is on, it'll be a safe indication. Now you'll notice at the very bottom, there's a set of toggle switches. Those are test switches, so that you can tell the integrity of the panel. Each one of those switches, when you throw them up, will put on both, turn on both lights, so that they're working. Because the worst thing you want to have happen is, a light burnout when you're relying on that to make sure that people are safe. And that panel also has the ability to put relays in it, so that you can do other things like you can turn on. Well, here, that's the next slide actually. So you can hook up annunciators such as a visual, like a light bar, or you could have a klaxon or a siren or something like that. And yeah, typical preventive actions of an RF safety monitoring system for loss prevention. Don't let that thing on the left, that picture on the left-hand side, happen to you. And very often, these kinds of things that happen can be largely prevented with good RF protection, good VSWR protection. And every meter that we build, they all work the same way. They all have 3-strike VSWR protection built into them if you choose to use it. I can't tell you how many stations they buy our meters and they don't ever hook any of that stuff up. All they're interested in is the forward power. And I will tell you, if I could give you, and you take away anything from today about any that I'm going to talk about, hook up that interlock connection to, so that your transmitter is protected for your, actually, it's not so much your transmitter, it's your transmission system that's protected from damage. Because, there's this idea that, well, I don't have to worry about the transmitter. All these modern transmitters have VSWR protection built in. They have fold back. Well, fold back is a great thing for the transmitter, to protect the transmitter, the PA and the transmitter, but it isn't protecting your transmission system. If you develop an arc in that system, and you can have a shift in the VSWR, all right, but if the transmitter may scale back to some power level that it's happy with, but that arc, once it starts burning away, is going to remain going. It doesn't need very much. You need a lot of RF to overcome the dielectric breakdown of air or whatever the dielectric is in the cable. But once that's exceeded, you don't need a whole lot to keep the fire going. So that's why it's important to remove the RF completely, and that's what our product does. You get 3 strikes, and then it's out. So yeah, don't let the smoke happen to you. Now, if you tie all this together, the power measurement gives you the safety panel for someone who is, has to do a quick assessment of what's going on at the site. Of course, you have these other things like the visual and oral monitors. Where I'll tell you where we supplied this kind of thing is the Hancock Center in Chicago. has one of these, and they have a bunch of our meters connected to it, and they have a door that allows you to go outside to the roof. And there's a strike on that door. If someone opens that door, when any of those red lights are on, it sounds a klaxon. And we also supplied them with a light bar system so that they can light up a light. So, that's what you can do to protect a site. And then, of course, you can measure, you can look at stuff with our app there, which is up in the upper right-hand corner. And then, of course, you can get email alerts about what's going on for that and for logging. Now, this is a large system that we did for the Empire State Building in New York City. We did this back in 2017. We were a subcontractor to ERI. It's an interesting situation up there. There are a total of 4 FM broadband antennas or combined antennas up there. There's the main antenna, which has, well, at the time when we did this project, it had 16 stations on it. It only has 15 now. One of them left. And there's that's what we call the ERI main antenna. And then that's the master FM. And then there's the mini master, which is the 3-station combiner that was built sometime later by ERI. And so what the Empire State Building wanted to do is they wanted to eliminate the need to use the old Alfred antenna that was up there, which is a kind of a historic antenna, because it limited the FM broadcasters and when they could operate when work was going on. When they operated on that Alfred antenna, they had to operate. They couldn't operate with the observatories open, so it limited work in the middle of the night and very limited time. So what they did to try to overcome that problem is they built 2 new auxiliary antennas that are up on the tower, so away from where the people are. And they were designed, of course, to have minimum downward radiation. So what happens is all 19, count them up, 19 of those stations, and it's kind of hard to see in this picture, but there are 10 of our motorized switch controllers, which I promise you I'm going to start to talk about remote controls and controllers and all that here probably in the next slide or two. There are 19 of them, 10 in one rack, 9 in the other. And the way this works is everybody has a motorized switch in their line to switch between their respective main combiner input and the auxiliary combiner input. So there are 2 auxiliary combiners, one with 10 stations, one with 9. So when we push the buttons up there, all those controllers operate the switches, which are installed, and they move over to the respective auxiliary antennas. And it's done in seconds. And then that allows them to operate in a provisional way. They can operate, they can have work done, they can transition through the inner part of the tower to get up to the top of the tower or near the top of the tower. The main antennas are turned off so they can go through there without any problem and work in that area. The only place they can't work is right outside of the, where the aux antennas are, but they can transition through that aperture on the inside of the tower, because the tower is a 4-sided tower and it's pretty large. So this system allowed them to do that. It really was a boon to productivity, because prior to that, you would have about maybe 2 to 2.5 hours of work a night that could be done. So projects took forever and it was very, very costly. So this reduced the cost substantially and the amount of time it took to get things done up there. And that system, as I said, has been operating since 2017. It was right around this time of the year. I think it was October of 2017 when we commissioned it. So when you got all those power meters, you probably want to have one place where you can kind of monitor all of them. And so we created this. This is brand new. This is our what we call panel viewer, and this is really designed for. I'm going to show a. Oh boy, let me see if I can do this. I'm almost afraid to do anything else here, but hang on. I can give you a demo of this thing, an actual demo. Where the heck is it? Here it is. Get it to start here. Now you don't see that, right? You still, what do you see? You see, or do you see my, what do you guys see? What do you all see? All right, I'm going to share again here. Let's try this again. Okay, let's see if this works.
Yes, I closed it so that you could bring up.
Okay, there we go. Now, can you
There
see
you
that?
go. Full screen, perfect.
All right. Is it really?
Yep.
Wow. All right, I'm not going to touch anything. So what this is this is a piece of software that we. Oh, by the way, let me back up a little bit. All of our products that are basically web-enabled products, every one of them now is SNMP. Okay, they're SNMP capable. Every product that we make is an SNMP agent. There are two styles of thing. You have an SNMP agent, which can take commands and provide status when asked. And then there are SNMP managers, which are the things that have all the smarts to say, I know where I can find that, and I'll ask for that information, or I know which relay to close and all that. That's a manager. That's a remote control, for example. That would be like a Burke or a Davicom or a Relio. Those are managers. Well, all of our software are SNMP managers, including this product. So what this is designed to do is that you can stack up as many power meters as you want on a tab. And you can have tabs for, I just have two running in the back here to show you what this looks like, but you can stack up, all 19 that we had there. Actually, there are more power meters than 19. Those are only the narrowband inputs on that system that I was just showing you. There are broadband power meters on every one of the antennas and every feed to every antenna. So there are another, let's see, 1, 2, 3, 4, 5. There are another 5 meters that monitor all those broadband outputs. So all that stuff can be displayed here, and it gives the managers at the site a very quick view of what's going on, who's on, who's off, and at what power level. Now you can, for network operators, if you have a network ops center and you want to, or even if you're trying to keep track of a market, you have 4 or 5 stations in a market. Well, you can set up those 4 or 5 stations on a tab, and then you can name them and do all that stuff. And you see, you have about, I think we have 8 tabs here, 7 or 8 tabs. And to set them up, you just go into this config screen here and put your IP addresses in and what you want to call it, and that's pretty much it, and save it. And you can set up another tab. You can name the tab and all that. So this makes it for a very convenient place to collect all the data, and you can see what's going on with that. That's something that we developed. This is actually, we just finished this one. We had an older version that we delivered to the Empire State Building a while back. We said, we need to do this a little bit better. So this is what this is. So I'm going to get rid of that and try to go. All right, Barry, I'm going to go back to. Let me try doing this again. All right. So are we
same as we were before?
I think what the problem is here is it has something to do with the full screen. That's why I didn't expand that other thing out to the full screen. You saw the whole thing, but it was
this is bigger. Anyway, this is bigger.
Okay. All right. Well, we're gonna stick with this. All right. So I promised I would talk about switch controllers and remote control. So that's this part of it. Well, as Barry, as you mentioned, we started doing RF support products back around 2007, 2008. And the very first product we made was a motorized RF switch controller for ERI. As a matter of fact, we used to private label it for them. And it was a basic controller, single switch and dual switch controller. And we got busy and started adding a lot of features to the product, and we ended up putting our name on it. And as a matter of fact, ERI still buys these from us, but they don't want us to put their name on it. They want our name on it, which is very flattering, I guess. But maybe we have a little different reputation in that area than they do. I don't know. But they said, well, no, when you ship us stuff, put the BDI label on it. So we do. So these controllers. We have a bunch of them, and I'm going to show all of them today. We have, well, in the variations, I guess there's 1, 2, 3, 4, 5. We make 6 different controllers. This particular one is the SWP200 controller. Some of you may have these. These can be ordered in either single or dual switch varieties, and they this particular controller was designed to meet the requirements of the following. A single switch controller will handle main and standby transmitter, pretty standard stuff. Provides interlock closures and external interlock inputs, all that good stuff. You can add our power meters to these controllers, and it forms a very powerful, so you plug in a DPS 100D or 2 into one of these controllers, and now you have automatic switching if you lose RF, if you want it, and you also have hot switch protection. If you have RF applied to a switch and you try to move it, through the controller, it won't move unless the RF is removed. So there's a couple of very important features by adding the power meters. Then we make the two switch version of this, which has the facility to handle, if you're doing a situation where you have a main standby transmitter and you have a main standby antenna, and you have two switches. Well, you're going to want the interlocks to control those two transmitters to work together for both switches. So if you move an antenna switch, you want the interlock to open for the transmitter that's selected to the air path. If you move the switch that is going to change transmitters, then you want to have both interlocks open and have it change position and then close the interlocks accordingly, according to the external interlock input. So this controller does all that, and it takes a lot of the guesswork out of it. I designed this product. Now, I won't say I co-designed the product. I was the guy with on the back of the envelope saying, this is what should be in it. And Ron Kumetz actually is the guy who actually did the hard work, which is designing all the circuitry and everything. But from years of my experience of having to put these stupid things in, and you're sitting there on the floor in the middle of the night, and you're saying, I got to get this thing in, I got to get the station back on the air, and you're trying to figure out interlock paths and all this nonsense. Where does this go, and how does that? What happens when I do this? This product takes all that guesswork out. There's one connector you connect your transmitters to. Transmitter on and off for each transmitter. External interlock input, the external interlock input to the transmitter is all on that same connector, and it's done for you. And when you push a button, everything happens the way it's supposed to happen, if it's installed correctly. Okay, so where are we? I got to move down some more here. Okay, so now that's the 200, and we added remote control capability to that basic controller. Anything that we ship now have actually in the last, I think the last year and a half or 2 years, I have to look back at the serial number that we actually did this on, but the new controllers that we make now will have a connector on the back. It's a D-sub connector that says IOX24 on it. And what that's for is to add this panel that you see right here that provides 24 channels of status, 24 channels of control outputs, relays, and 8 additional, well, it says additional because this slide got mixed up. I'll explain why in a minute, but 8 analog inputs. So it turns it into kind of a full remote control at that point, and it's still a switch controller. So for a fraction of the cost of a real remote control, I shouldn't say real because this is a real remote control, and a motorized switch controller from brand X and brand Y, you get everything in one package here for a very, very low cost. Probably roughly, depending on whose switch controller you were to go buy, one from our competitors, it could be as much as saving half, because some of these controllers get to be pretty pricey. Okay, so which slide am I on here? Oh, here we go. This has got a GUI, and that's what it looks like. Actually, I can pull up a demo of this. So let's do that. So Barry, do your magic there. I have one of these online here. Where is it? Well, this is actually the 300, but that's okay.
Okay.
Hang on one second. All right, so now, if you want to go ahead and let's see, can I have to share this?
Go right ahead.
All right. Well, if I do that, it's going to disappear on me. Hang on a second, guys and gals. I know there's a few ladies here, so, or at least one anyway. I saw Mary. I don't know if there's anybody else here. I don't mean to leave you out, Mary. So, all right, let's do this. That's not what I wanted to do. I don't want to do that. I want to do that. There we go. So I don't know what's happening here with this. You're not seeing it now, are you? What are you seeing?
White bar.
That's it? Really?
It's a nice white bar.
Oh, well, tell you what, let's stick with the, oh boy, look, I'm very sorry about this. I don't know. It's Bill Gates' fault. It has to be. So let's do this. Let's just, let's go back to, all right, I hit that. Let me go back to this here. I'll just basically describe this to you. I wish I could show you the demo of this, but so anyway, what you get here, I hope you can you all see that now? Again. Okay.
Yeah.
All right. So what you get here is this is our app. And again, this is an SNMP agent app. And what it gives you is the positions of the switch or switches. This happens to be a single switch controller. And you'll notice the two paths is transmitter 1, transmitter 2. Transmitter 2 is selected to air right now. And there are 2 power meters connected, and that information is right here. So for each load path, you see there's a power indication. There isn't any power going to them at the moment. And you'll also notice that the transmitter 1 interlock is open. And that's because that's feeding the test load. And, you have to turn on your air or your water, and that will close an interlock switch, which is connected to the back of our controller, and that would close. So you get complete status of what's going on, what's on the air, and what your interlocks look like. And then this down here, it's too tedious to keep going back and forth. I really wish I could have just shown this, the actual app itself. But I'll tell you what I'm going to do. I will send Barry the IP addresses and the ports to get in on these. And if you go to our website and download these apps, you can play with these to your heart's content, because we have these units up in the rack there, and that's what they're there for customers to take a look at them. So feel free to go in and break them at some point. So in any case, this gives you what is called the dashboard screen. You can go into control, and you can do all the same stuff that you can do with everybody else's remote controls, even macros and logging and all that kind of thing. So you can set up these buttons over here. I had set these 2 up here to turn an air conditioner on and off. And when you push that button, the green button comes on. When you push that one, the red button comes on to say it's on and off. So it's a toggle. I just assigned that to a relay, and that's part of the system, and that'll turn your air conditioner on or off, for example, or whatever you want to use it for. Things like switching transmitters, switching the switch to the other position, turning on the air and turning on and off the transmitter that's selected to air, all buttons that are all done for you already. You don't have to create a macro for that. It's all there. And then we give you some external status for if the transmitter has an on status, you can feed that to these buttons here, which actually are just indicators, and it'll tell you whether the transmitter is actually on or not. So that's pretty standard with, let's see, let's go here. Yeah, actually, I skipped over a slide here. So that was the 200. Then we make the SWP 300. And it looks just like the 200, because essentially it is, except that it's got some extra stuff in it. It's a motorized switch controller. You can get this in the single switch or dual switch variety, just as I described before. But it also has, in this single rack unit, 16 control outs, 8 status ins, and 4 analog inputs. Now that may sound like an odd pairing of stuff, but you got to remember that a lot of the things that you would normally eat up statuses for and whatnot, we already take care of with connectors on our unit. Now, if you need, so if you need a basic system, I need to move switches around. I want to monitor the power, so I got a BDI power meter. I can plug that in. I can see that, and I just need to keep track of a couple of statuses, and I need some hard closures to do things at the site. Relatively simple site, and you need a motorized switch controller. There you go. All you need is this thing right here in the middle. That's the rear panel of this. And then you say later on, well, this site's growing. I need more stuff. I need to be able to control and monitor more stuff. Well, all you do is buy one of these from us, put it in the rack, plug it in, and then just make a connection on the rear of the unit. That IOX connector is right here, as a matter of fact. And that's it. You're done. There's no configuration. There's nothing you have to do. You just tell the app, hey, I look for the IOX panel, and next time you start the app up, and that's pretty much it. So this gives you a really, really powerful remote control system when you're all done, and at a fraction of the cost of some of the other ones. And again, I want to point out, these boxes themselves are SNMP agents. So that means that they can be used with these more expensive remote controls as a peripheral device. So if you have a Burke system, or you have a Davicom system, or a Relio system, and you want to use our product with those, we have a MIB for every one of these products. You just read it into the device and go ahead and do your configuration, and away you go. So in a way, you can start out very basic with this. You grow to this. They say, I really need much bigger than this. Then you can go buy yourself, Mr. Big Guy's remote control, and this still becomes a peripheral. You don't have to reconnect anything. You don't have to change anything. This just becomes a peripheral on that system. So I wish you'd buy a remote control from us, but we realize there are some limitations. And we designed this remote control really to be to fill the gap between the really, really, really cheap stuff that everybody knows that's out there, that's about $1,000, $1,500, and the really expensive stuff that's $5,000 and $6,000 and on up. So we're kind of in the middle there. And this has become a very popular system. As a matter of fact, Mary has sold a few of these for us this year. Thank you, Mary. And customers are very happy with them, from what I understand. So these work out real well for folks. Okay, so let's continue on with the next switch controller that we make is this one. It's called the ISC 200 Independent Dual Switch Controller. Now, why is this different than an SWP 200 2T? Well, if you recall, the 2T that I described earlier has a specific job to do: main standby antenna, main standby transmitter. This one is simply two very basic motorized RF switch controllers in one box. It doesn't have a lot of fancy stuff, but you can connect two switches up, 4 transmitters, 2 on each one, and they're completely independent of one another. So the interlocks for one switch work with one pair of transmitters, and the interlocks for the other switch work with the other pair of transmitters, kind of like everybody else does it. We never had this product, so we decided that we needed to do this. Again, it's an SNMP agent. You can control it through your Burke remote control or Relio or Davicom Cortex, whatever you might have. We, of course, every product that we make, we offer a GUI. That's the GUI for it. You'll notice that there's 2 tabs here, one for switch 1, one for switch 2, and you can control them independently. You do have some control here. You can turn the transmitter on and off, like that. There's also a logging function. All our remote stuff has logging now, so that every time the switch gets moved, you can log it to know what time it got moved. And you can download a CSV file of the log, and you keep that stored away if you like. So again, if you just need a 2-switch controller and you don't need a lot of fancy stuff, you just need to be able, you got maybe two stations at a site, and you have the same kind of thing going on at both sites, where you got a main and a standby. One station doesn't have anything to do with the other. This is the product to do that with. All right, what else have I got in my bag of tricks here? Okay, now this guy, oh boy, I really, I'm gonna try and show this one. I'm gonna try and do this one. This is a brand new switch controller. This is the last of the switch controllers. This is a 3-switch controller that has a very specific function. We've run into an awful lot of master antenna sites where they have the typical configuration is there's a power divider coming out of the combiner, power divider, upper and lower bay. So you have basically, and then the requirement is to be able to bypass around the power divider to go to the upper bay or the lower bay only. And there was really never a good product to do that. You could cob together motorized switches to do it, and you'd have to figure out maybe a way to do a macro or whatever. And then you had to have a custom panel I push this button, it's going to operate this switch and that switch through this controller, and it gets to be a real nightmare. We consolidated all of that down to one chassis. And so you plug 3 switches into this. And okay, Barry, I'm going to try this. Worked before. Let's try it. PDC 300. So let me bring this app up here. And let me share this screen. I think this is going to work. I really do. I think it's going to work. How's that? Can you see that?
Yeah, I can.
Okay. All right, good. All right, so this is the app for this controller. And again, this is an SNMP manager app for this controller. And what it does is it gives you a graphic of what's going on. Now, we delivered one of these actually this past summer down at the Senior Road tower site in Houston, where they have one big system. They have 9-inch transmission lines coming out of the combiner, feeding the power divider, which is a hybrid, actually. That's the way this is actually shown here. And then they go to 6-inch line, or do they? No, I'm sorry. Everything is 9-inch in that system, all the way up to the tower. Well, these are all Class Cs, and they have 10 of them. So there's a lot of power going through that system, about 195 kilowatts. So they have 2 sets of 4-port switches. They had originally, when that system was built back in 2005, we did the original. Well, we didn't do the monitor system. What we were charged to do, we were working with ERI at the time, and we were asked to provide an interlock system and some other things. And we did that at the time. And it came time to replace all of that. And they wanted a new monitor system. ERI provided their own monitor system at the time. And, you know, after that, they decided that probably wasn't a good way to go. So they started using our stuff. They still make some kind of a system. And I don't know how many of those they sell or what they do. But, you know, all I can say is when the rubber meets the road and they have an important system that has to be done, like the Empire State Building, which was a very, very big project for them, they chose us as a subcontractor to provide that system. In any case, when it came time to redo this system, we got the job to rebuild the monitor and protection system. Pardon me. So we provided our standard power meters and a new switch controller that we developed. And this is what it is. This allows for the normal operation of the upper and the lower bay, which is what's shown here. You see the green lines are showing all the paths that are going from the combiner. That says TX, but that's really combiner output, but you can call it anything you want. And it's feeding the power divider, and then you have the upper and the lower bay are being fed by the other 2 switches. But with the push of a button, either here or on the front panel of the unit, you can switch this to, now that's upper bay only. And you see the green path. So you have your path, you see what's going on. And I can do lower bay. And, note that when we're on the upper or lower bay, you'll notice over here on the right, it says half power. And that's generally a requirement with most of these systems. You cannot feed 200 kilowatts through one single 9-inch transmission line. So we have to cut back to half power. So we issue a command, a status output from this controller that tells the stations, hey, you got to go cut to half power. And they all have preset power in their transmitters to do that. So that allows this to be a very, very seamless operation. Now you'll notice over on the left-hand side, Ron, are you on with us? Oh boy. Well, anyway, I wanted to demonstrate this. Let's see if maybe he's finding his microphone. Ron Kumetz, who's our director of engineering, was supposed to be on this with me, and I don't know that he's here or not. But in any case, I'll have to do finger puppets for this. You'll notice over here on this side there are a bunch of interlock inputs. The controller has 8 interlock inputs that you can use. So power divider input, that would be right here. And that's, in other words, that's right here, actually, the input to the, oh, okay. You are there. All right, Ron. He wants to be anonymous, apparently. You can say hi to everybody if you want. He lets me be the ham. So what Ron just did is he opened up the power divider input interlock. So this would be like if you had a patch panel or a lockout tag out or something like that. So that interlock is open, but that also means all the stations are now off because the interlocks will open. So you can proceed to go through the rest of these if you want, Ron. Just run through the rest of them here and show you what happens. So there's the upper bay, and you'll see that path now is dead, which means you're not feeding any power, and that's also going to shut everything off because the and he's doing the lower bay, and then the reject load. This may be lagging a little bit when you see it, but that should turn red here in a second, I guess. Now it's lagging a bit because it's going through that thing called the interweb, but In any case, that's the way this works. Then we gave you a, you can turn that back on again, Ron, if it's still
You need
off.
to, do you need to hit test load?
No, yeah, you can do that if you want. Ron, if you can just run through the rest of them. I don't know what happened here. Maybe this, there you go. Test load. That's to show that, oh, and that system had they actually have a test load for that system. It's a water-cooled load. And you want to talk about having it be very important that you have an interlock switch from the water flow switch to the controller. This is one place where it's very important because there's 200 kilowatts that can smoke that water cooled load in about a microsecond. So then we provided a system interlock input, which is just a generic input. So if you just wanted to have a panic switch to shut everything off, you could do that literally with a toggle switch or some kind of a push button. Now, force half power input. If you do that, that provides that status output to all the stations to say, go to half power, even if you're not in one of the half power modes. And then we also added the RF safe input. And what that's for is if you, this system, by the way, has power meters. They're not shown here on this app, but there are power meters here, here, and here. And so if the RF safe input is lost, in other words, what happens is there's a closure on the power meter, as I discussed earlier, that you can have close, change status when power is either removed or is there. So if power is there and you try to move this, it's not going to move. So, this one thing we needed to finish. It's in the half power mode now, I guess, right, Ron? I guess it is. And it's also, let's see what happens here. It didn't move. And the reason it didn't move is because the safe input isn't enabled. Okay, so that means that there's RF applied to the system. So it's remaining in that lower bay, which is where it was before. So that's also a very important one. So, okay, so that's the PDC 300. What else have I got to show you? I think we may almost be done here. So let me go back to my, oh, I'm not done. Okay, so now we're going to share one more time here, Barry. There you go. There you go. And there you go. Okay, just one more chassis that looks like all the rest. You notice that we try to economize on parts. So we use the same parts for an awful lot of products. So this is our antenna monitor product. So this kind of closes the loop on all the RF safety stuff and all that. But this is used in an awful lot of combined sites. We have a lot of these on the air around the world. And what this does is this chassis is designed to accept up to 8 of our power meters. And they can be in various locations. As I showed you before, you could have, on the broadband outputs of the combiner, the upper and lower bay, you can have, one on the combiner input, and then you can have a bunch of narrowband inputs. So the way this thing can be configured is that it will show the power levels from all of these combiners, or from all of these meters they're monitoring various parts of the combiner. But it'll also provide a smart interlock system, in that if you have a fault on one of the broadband meters, either the upper bay, lower bay, let's say in the case of a two feed system, or the combiner output, that will open the interlocks to all stations. Every one of the interlock relays are open. You can have up to 24 interlock relays in one of these chassis. If you have a fault on one of the narrowband inputs, that is one of the combiner inputs, it will open the interlock to that station, and they can deal with whatever problem they're having, and the rest of the stations remain unaffected by it. So it's what we call an intelligent I guess is a pretty smart interlock system. And this also is an SNMP agent. You can gather all the data in one MIB that can be fed to somebody else's remote control. We also have an app for that. It's called the BDI stack. So there's one little compact little screen that gives you all 8 channels. I think we only have one of them at the, or no, 2 of them are activated at the moment. And yeah, the only remote control you get with this is the reset here, which is if you have a fault, you can hit the fault reset and that'll restore the VisWire protection. And then if it's a sustained fault, it's just going to go right back off again. That's what the 3 strikes are for. And then this can be configured. You can call these channel names different things and whatever, and it gives you the basic information. Actually, I have this. I can make this a little bigger. Hate to keep doing this to you, Barry. Where is it? BDI stack. Okay, let's share this. I hope. Let's see what happens. Let's stop this share and let's try this again. There you go.
Yep.
Does everybody see that?
Yep.
I can make that a little bigger too. Well, maybe no, maybe I can't. So let's leave well enough alone. But I gotta figure there's got to be a site someplace called High Mountain. I made that up, but you know, you can name the site and you can have, as you can see here, can you see the big BDI logo over here where it says stack? Maybe you can't. Maybe you can't see that. But what that is, that's the open screen. And you could have 5 of these that you could have different configurations for 5 different sites. This is for smaller systems. If you're going to have a large system that's got 10 or 15 or whatever modules on it, and you need to have monitoring all of that, then you want to use that product that we showed earlier, which is the panel viewer, because that's really gives you a better view of everything. This is still used as an interlock system, and we can stack these. We've typically done with larger systems, and I think we did this down in at Senior Road, for example. Well, we did it at Empire as well. You'll have one chassis for broadband events and another chassis for narrowband events, and that way you have, you know, you can do 8 broadband meters if you had that many, but generally you don't. And then you can have 8 narrowband, and if you have more than that, you just add another chassis. So you can gang these. And the nice thing is you can monitor all of that stuff with that panel viewer. You don't have to worry about this. This is really there quietly in the rack doing its thing, and it's controlling the interlocks accordingly, which is also a very important part of this. Okay, so let's get rid of this. Let's get rid of that. What else can we show you? I think we're almost done here. I think we are done, but let me go back to here. And well, I have one more screen here, which is this is a typical kind of thing that you could create yourself if you wanted in a remote control or whatever, if you wanted to do it, but it's kind of hard to see. But we have our BDI app, power meter apps up here showing the various locations on a tower where the power is. And so you can get a little better view of where things are on a tower and what the levels are there. Okay, I am going to do this one more time. I think that's the last slide anyway. The last one is, you know, buy stuff from us, you know, buy often and all that good stuff. And thank you for your attention. But before I do that, let me, I just want to show the newer DPS 100D app, because Alexi worked very hard on this to make it even more better. Oh, wait a minute. I got to open up one here. Sorry about that. Let me get rid of that. Okay, now that should show up when I go to share that. Okay, let's see what happens when we do that. There you go. Okay, so can you see that?
You're learning to do the whole thing now.
Oh yeah, wow. I never do my fingers leave my hands. So this is a DPS 100D power meter app, and oh, look at that. It happens to be on a 2 meter frequency. I wonder how that happened.
Good man.
Yeah, we we made some changes to this app. We added some things to it. If you were out at NAB this year, with this was out there. I wasn't, but I had a very, very smart representative there demonstrating this. And we added, you always had this page here where we have the forward reflected power in numeric form, but we never had meters. So there you go. Now we have real meters. You'll notice that you see green and you see red. This is based on the full scale and where you have your high and low, power limit set, where you want to be notified or whatever. So that's what these things are. So these are the 6 things that can be shown with a meter. And they're pretty easy to set these things up. I guess you can see all of this stuff. So if you go in here, you can set up all this stuff. Well, how about that?
Is there a way to see trends like over time?
Well, yes, in a way there is. You can log events. That's the best way to see trends. If you're asking if there's graphically a way to do it, no, not currently. But you can do a couple of things here. You have events. If you set up in the setup here, if you go here and you set up these alarms for various things here, low power, reflective power warning, VSWR fault, et cetera, et cetera, et cetera. And you enable these things, you can then keep track of when these things happen. You can also, so when you do that, you can create a log, and I'll show you that here. In other words, you can set up a log recipient email address, and every so often, you have frequency here. 15 minutes or what's going on here? Oh, wait a minute. It's because it's covered. I can't see it. You can set this up for various, there we go. 15 minutes hourly or daily. So in that respect, if you really wanted to have trend information, I suppose you could log every 15 minutes. I'd be careful doing that. We had a customer that was doing that, and they got themselves in a little trouble where things were piling up. But I'd suppose hourly or daily, you can do that kind of thing, and it'll give you a log of events. But we don't graphically show it. We've talked about doing that, and we just haven't. It just hasn't been a priority for us. But if really people really thought that was really interesting to see, we could do. If we felt the logging was probably adequate to give you, some kind of trend information, you could see what was going on over some period of time.
Yeah, if things tend to get fairly complicated.
They can in a hurry. You're right. Yeah.
And it's real easy to look at a page full of graphics and say, oh, the VSWR is trending up. It hasn't hit the red line yet, but I better go out and figure out, is there moisture getting in someplace?
But I tell you what, we've got something better than that.
Oh, good.
Well, no, I mean, seriously, if you set this trigger on VSWR, okay, and then you come over here and you say, where the heck is it? We come over here and we say, when the VSWR is, well, let's set some realistic faults with things in here. Let's do 1.5, let's say, for the fault. But let's say your VSWR normally is about 1.05. You got a really good antenna, but you want to know if it goes above, let's say, about 1.2. When you do that and you set an alarm for that over here, oops, keep switching to the wrong thing here. I'll get there. Oh, the alarm pay. Okay, there we go. If I set this up now, I can do a warning and I can do a fault. This will send you an email and tell you, because you may not be looking at it at a particular time, okay? When you're starting to have trouble, it's going to tell you, okay? Here's where this is also very important. This is one that's overlooked a lot. Pressure, line pressure, okay? Here's the scenario. This is like the old, I think it's probably a vaudeville routine about, the rich guy comes home after being away for a month, being overseas, and he comes back and asks the butler what went on while he was away, and he said, well, the dog died. You know how the rest of that goes? Well, That's just the tail end of what happened. You know, the dog died when, well, how'd that happen? Well, that happened when the doghouse caught on fire. Well, how'd that happen? Well, it went up when the main house went up, and it just gets worse and worse. Well, it's the same thing with pressure, line pressure, because typically here's what happens. You have a line filled with either dry nitrogen or dry air, and it springs a leak, or the dehydrator dies, or whatever. And gradually the system begins to leak off. And you may not be paying attention to it on a daily basis. But if it drops to some level that you say, hey, there's something wrong here, I want to know about this, it'll send you an email. You can set up it to email you when that happens. That's better than trend information, in my opinion, but that's just my opinion. I mean, I get the point about having a graph. It's nice to look at all that, but I'd rather know. And this way you're not waiting until, because here's what ends up happening. The pressure goes to zero. You don't notice it. You don't get to the site very often. Now the line begins to fill up with moisture. Then it arcs over. Then it starts the fire. And remember that picture I showed you earlier with the smoke coming off the tower? That's what you end up with when I'm sorry, but I think it's better to have an email or some kind of a condition that says, you better deal with this now, or I'm telling you about this now. So that's kind of our way of handling. I think
the thing is, here's the ideal example. So you have a dehydrator, filling your feed lines with air, and on a graph you see. Normally what happens on a graph is you see the pressure go down to the set point of the dehydrator, and it kicks on and it comes back up, and it goes down, over time. So maybe you've noticed that your dehydrator is, turns on, twice a day. And then you look at the graph next week and, it's been turning on, every 2 hours. It never hits the set point where it's going to alarm.
Sure.
Because the dehydrator turns on, but you've got now a leak that's getting worse and worse and worse and worse. Never hits the set point to send you an alarm. If you had an alarm set lower than that, it would set you an alarm. You'd have to have that set point set, above the dehydrator's startup threshold.
Well, I would. Yeah, I would only say two. This is we could debate this all day.
No, I'm just saying.
I understand what you're saying.
There's a value.
I get it. I get that. I understand that. I tell you what, my quick answer for you is, this is in the MIB. So feed it to your remote control. And
okay.
you can set
Harold's
that up
had his hand up for quite a while here, so let's hear from Harold.
Hi, Harold. How are you?
Doing well. Hold on a second while I stop a teletype here. All right, back again. This is pretty impressive. And the SNMP.
I'll tell you what, coming from you, that means a lot to me.
Well, I've been away from it for a long time, and you've really moved on. I did some SNMP work a while back, and I think the S for simple is inaccurate. It is a pain to code.
Well, it can be, yeah, it can be.
I was doing it on a microcontroller, but back on power measurement, is normally on accuracy. I've seen it as percent of full scale. Is that what the rating is?
No, there's a big difference, and I'll tell you what that is. Our meter is, as I said earlier, is it's so much error as a percent of indicated reading. And here's what that means. I used to do a presentation on this, as a matter of fact, but here's basically what it means. It means that within the dynamic range of the meter, which in our case is 40 dB, so if the full scale is 10 kilowatts, for example, you can measure accurately down 40 dB below that, which is what? Is that 1 watt? Or I always forget where we are. It's in 10 dB increments. So your kilowatt, 100 watts, I guess it's 10 watts. So what that means is that any power measurement within that range is going to meet that maximum, no more than the maximum error of plus and minus 5%. Okay, that's by definition what that percent error per of indicated reading. That's what it means. Now, traditionally, the old slug type meters, the diode style meters, they are spec'd at, you're quite correct, they're spec'd at so much of a percentage of error at full scale indication. Okay, but here's what that really means. So if that meter, I think the diode slug meters are typically the same percentage of error, about 5%, but that's at full scale. So if you think about that, if you now drop the power down by 3 dB, so you got a meter that has a slug in it that reads, that has 10 kilowatt full scale, and you drop the power down to 5 kilowatts. What's your error now? Now it's 10%, because it's still plus and minus 5% of full scale. And you drop down to below, keep going, you can get all the way down to, and your error just increases. And we know this, we've seen this in practice, because if you have that's why they always used to tell you, well, you have to have a meter indication. The old analog meters, you have to have an indication that's within the top 15 or 20% of the meter. Otherwise, you're not going to have accuracy. The problem with diode style meters for that kind of accuracy, the reason they don't have that kind of dynamic range is because they're using a diode in the square law region, and that's a very narrow region of operation, about a dB, something like that. So and they work fine. For the most part, most of us are interested in a transmitter puts out 9 kilowatts. So you buy a meter with a 10 kilowatt slug and life is good. But if you're in a situation like what I was showing before, where you have to be able to accurately indicate half power or a quarter power or something like that, ain't no way you're doing that with a diode style meter, not accurately. And especially if you're going to use it in an application where you're going to use it in an RF safety measurement program to say, well, when this antenna is at 25% power, it's safe to climb through that aperture, that kind of thing. I think that's where it becomes very, very important. The other area where the dynamic range is important is when you're trying to measure digital waveforms. The diode style meters just don't have the ability to track the crest factor of some of these these digital waveforms, and it's because of the lack of dynamic range. So you get an average, you get a true average, RMS sum out of this style of meter. It's I used to do a whole presentation on why these meters are different. But it's absolutely a great question. It's a great question to ask.
So yeah, I remember analog meters were typically rated as plus or minus 2% of full scale. So if you were considerably below that, your error was considerably different. Right. And for AMs, changing power, you do need to deal with considerably lower power. Now, right. That does bring up a couple of other questions on these. I don't know how you would describe it. It's the through line type meter. What is the frequency response of these? Is it are they wide frequency range, or how much error do you get? Does it slope up in frequency, or what does it do?
The answer is it depends. Most of the directional couplers that we use for FM and television use are what are called bidirectional couplers, and they typically have a slope of 6 dB per octave. So they in other words, they rise in response by 6 dB per every octave change in frequency. Generally speaking, let's say for FM, these directional couplers will vary about a dB and change from 88 to 108. We take care of that it's a kind of a proprietary method. We know exactly what the coupling loss is on every frequency, and we account for that. So that's how we. And by the way, like this meter here, you notice it says 146. I can change that to this particular meter, by the way. The reason it's reading this meter has a, let me let me give you the other answer on what you asked about the directional couplers. We can supply directional couplers that are flat, generally within about a half a dB to a quarter of a dB, plus or minus a half a dB, something like that, or a quarter of it. Sometimes they're even better than that. From 80 meg, let's say, to 1,000 megahertz. As a matter of fact, this meter that says 146, that's exactly what that is. I think the last time I used it, I took it up to our repeater site for our local ham club, and I had to measure the power output. That's why it's still on 146. That's a small little meter. It's an N-type meter. But you can actually go into the web page on initial setup, and you can change the frequency. And when you do that, it's calibrated on that frequency, as long as it's within the range of the. Well, it won't let you put in a frequency that's not within the range of the directional coupler, but these meters are actually frequency agile in the field. We make it a little harder for the broadcast product to do that. You have to go, it's because generally speaking, a broadcaster is going to put this on a frequency and it's going to stay there. If you need to change it, take it from one site to another, you can do that. You go in, you power cycle the unit, you go into there's an HTML page, and down there at the bottom, it says frequency, and you can put the frequency in and it'll take it. Now, I think I know why you're also, what you might have a follow-up question. Well, if you have that slope, how do you compensate for that when you have multi-carrier? Well, the answer is twofold. One is that generally speaking, for FM use, we've typically not had any difficulty meeting the plus or minus 5% of indicated reading over a range. But we basically look at all the frequencies that are involved, let's say in a multi-station environment. We'll average it and figure out where that needs to be, and that's the number. And generally speaking, you can stay pretty close, because I mean, if you figure it from 88 to 108, you've got about a dB change. Generally speaking, they're all bunched together someplace. They're either up at one side of the band or the other. There's very few where you'd have one at 88.1 and 107.9. I suppose there are systems out there like that, but generally speaking, that still gives you an accurate summation. That's the other thing too, by the way, the big difference between diode style meters and true RMS meters, reading meters. True RMS meters are very similar to the old thermocouple style meter, where you feed it RF and it'll just give you the sum of all the carriers. Same thing with the true RMS meters that we build. Diode style meters, they're not suitable for multi-carrier because they'll create other frequencies. Remember, this is in a square law region, and you can fall out of that square law region very easily, and you end up with other signals in there, and they all get summed together. And so they're just not. I mean, in television, for example, in the old days with NTSC, you'd always have a thermal meter on the visual carrier, and then you could have just a diode style, bird style meter for the oral carrier if you had separate. They were being done separately. These days, that doesn't work anymore. You have to have you got to use a true RMS meter to measure any of the digital stuff.
Quick calculation, if I did it correctly, I think the FM band is 0.3 octaves from one end to the other, so your worst case error would be 1.77 dB.
Yeah, it's never that. Yeah, it's never that bad though. It really isn't.
I would be, if you were doing 88 and 108.
Yeah, but it's never that much. It's generally less than that.
Is there something, physical construction that would flatten a coupler so it's not 6 dB per octave?
Sure, absolutely. You wouldn't use that style of coupler in the first place. That's why I say if it's really that stringent and you really needed an absolute flatness, within, let's say, well, first of all, we build, as I said, this meter here, this one's 80 to 1,000. And I can tell you one thing, if you put it at 450 megahertz, in other words, that's a frequency agile meter. In other words, we actually private label this style of meter for another company. And pardon me, we have a frequency entry right here. You can actually put it in, through the app. And when you hit return, boom, it's on that frequency. But those couplers are so flat that generally you can put them right in the middle someplace, and they're never going to be out of, you're never going to be more than about a quarter of a dB off. Now, a quarter of it.
Bob?
Sure.
Yeah, Ken Fine's got his hand up, and he's been waiting for a while.
I'm sorry. Okay.
The
person asking the questions has been off screen. I haven't been able to see who that is. Is that okay?
That was Harold. Ken.
Oh, Harold. Okay. All right, Ken. Let's see. What do I do? Do I just click here, or what do we do here to get him to?
I can just talk to you.
Yeah, that'll work.
Okay. On your one transmitter to two antennas unit, could you put a hybrid ring type power combiner instead of the power divider and have two transmitters combined into one antenna system like 220s to make 40
Yes.
kilowatts?
Yes, we do it all the time. Not as often as we used to, but yes, you can do that. We've had customers that will buy a meter for all 4 ports. They'll want to see what's, from each cabinet, what's going to the antenna and what's going to the reject load. So absolutely, you can do that.
Thank you.
Okay.
Harold, I think you had another question bubbling up.
Always. Thank you. The meter you mentioned, the frequency agile, where you key in the frequency, it sounds to me like that's perhaps using a coupler that does 6 dB per octave, and then you're correcting in software. Is that what's happening?
It's not. It uses a completely different style of coupler, and if we needed to supply one of those, we buy this from the company that we private label for. Okay, this company makes they make directional couplers of all sorts, and every variety, and they have a lot of patented technology. If you need a coupler that's that flat, they're the go-to guys. And so as I said, we had to design a meter that would be frequency agile, would be flat, would we all do all of these things, we to operate over all these ranges. We've made meters for these fellows that the typical, we make a bunch of models for them. There's a 1.5 meg to 32 meg. We make a 1.5 meg to 150 meg. We make they keep hitting us with these different power ranges and different frequency ranges and power levels and all that stuff, and we just do it. There's really not a lot of limitation on the sensor. It's the directional coupler that's the real limiting factor, as you point out. But they have good technology. It's a company called Whirlitone, and we've been partnering with them for about 6 or 7 years now. They're another local company. They're right near us here in New York. So when they tell you that we don't manufacture anything in New York anymore, they're wrong. So
yeah, I just had various questions on how directional couplers work. I assume you're getting an RF sample from them, and then doing RMS to DC conversion in your instrument, or
that's pretty much how it works. Yep. Got it.
Very good. I think I remember a chip from Linear Technology that actually had a heater in it and then measured the temperature.
Yeah, there's a bunch of them. There's a bunch of different. There's a lot of parts to do that now. The wireless business is really what spurred all of this. What really spurred all of this on. But these sensors are in everything these days. But there's a lot more to it than just taking a sensor and saddling it up to a directional coupler, and a lot of that is proprietary, which I won't go into because I'd rather our competitors not know how we do what we do. But suffice it to say, it's been an education for everybody involved here on our part to do this and do it right. The challenge of having to be able to make a meter that will measure 80 kilohertz, and there's that they've got applications down to 10 kilohertz where they're making an electrical waveform at a 10 kilohertz, not audio. We're talking about an RF waveform. Well, of course, you know what that's used for. That's the kind of stuff that goes in submarines and that kind of thing. But we've had to be able to make a sensor to be able to measure that stuff. And as I said, in different ranges, we can do any of that. But we don't market and sell those as a BDI product. That's made. But if you want to buy a meter like that, you can buy it from a company called Whirlitone, and they'd be more than happy to talk to you about it.
Thank you very much. You've answered a lot of questions. Thank you.
Okay, you're welcome. Well, I'm pretty much talked out here. Are there any other questions or comments or anything like that? I'm here all afternoon.
Anyone else have a question for Bob about any of his controllers? Or I know one of the things you mentioned very briefly in passing this time, but we went to greater detail last time, is that you can really help out with this with the codes. that manufacturers have for additional features or data or something that you can bring into your systems, right?
Well, I'm not sure what you're asking. In other words, are you asking whether, like with our remote controls, can we read a Nautel transmitter with an
Yes.
SNMP MIB? No, we can't.
Oh,
We cannot. And I'll tell you why we don't do that. We could do it, I suppose. We want to throw a lot of resources at software, but there's a reason why we don't. We think they do an awfully good job with their own app to look at every parameter that's in that transmitter. So our view on this is that we give you the essential stuff that you need. It's all the last couple of feet items, you know, the relay closures, the status inputs, that kind of thing, the motorized switch control stuff, all that stuff. And if you really want to drill down into your transmitter, your Gates area, or I don't want to leave them out. I mean, but you know, but any of the transmitters, Ronan Schwarz, for example, or any of them, pardon me, they make much better apps for that kind of thing than I'm just from a business point of view, it doesn't make sense for us to spend our resources, our precious resources, developing anything like that.
no, I thought somewhere in your last presentation, you showed that you got a table of those MIBs from the manufacturer, and there were ways for the user to incorporate.
Well, I think what you mean is the other way around. We provide our MIBs to everybody else, and they can ingest the stuff in, and they can read our stuff. So
maybe I was standing on my head. Could have been.
well, yeah, you got a better memory than I do if that's the case. I don't know, but maybe I should do that more often. Maybe I should stand on my head more often. But no, we really chosen it. We talked about doing a lot of that stuff, and we said, you know, by the time we get done, you know, it's a different product at that point, and it's going to be more expensive. And that's not our aim. Our aim was to come up with a product that was less expensive than the so-called big guys doing remote controls, but give you more features than the little inexpensive, you know, touch tone pad kind of deal remote controls. You know, we're offering a full remote control that is web enabled, it's SNMP enabled, and you know, does all the hard stuff for not a lot of money. And that's really was the goal. And that's why we didn't choose to go into, you know, coming up with very elaborate stuff to read in all these. I mean, there are other ways to do that, by the way. And you know, that there are software only solutions for that. Roden Schwarz happens to have one, for example. They I don't mind blowing their horn. They're a good customer of ours, so they buy stuff from us. And they have a really nice software package that not only to monitor their transmitters, but just about anything else, our stuff or anybody else's. There's a company out on the West Coast called MNC Software. Some of you folks might be familiar with them. They're the SNMP people. If you want to monitor something with SNMP, you can just go to them and they can do it for you. So, you know, again, we've provided our MIBs to them, and they've provided custom solutions for customers using our stuff and everybody else's. So, you know, to be perfectly blunt, I mean, if you're perfectly honest, we're a small company. We have to watch our resources, and that's just not a place where we want to put our resources at the moment. Simple answer.
Hey, makes sense to me.
One more thing I want to say before we part company. If Mary's still here, we ask you that if you're looking at buying product from us or looking at our product, we hope you do, to support our dealer network. And Mary's somebody you can talk to at Broadcast Depot. She does a really great job for us.
Mary had to tail out a little while ago.
She had to, well, I'll tell her later that I said nice things about her, but seriously, I mean, it's our dealer network, and we have good, you know, we have good relationships with all of our dealers, and I singled her out because she was on the call today, but we have others too. So,
Bob, we really appreciate you taking the time and sharing us the information, walking us through the products.
Well, I appreciate being here, Barry. Thank you for giving me the opportunity to bloviate ad nauseum.
Do again next year sometime.
Okay, we will do that. Thanks, everybody.